Hello, Berkeley High students. This is Mrs. Francis. I hope that you're having a great day. Today, we are going to be exploring the quantum mechanical model, which is our latest view of the atom, specifically focusing in on where electrons might be found. Now, this is video one. We'll have a series of videos and live instruction for you. You have the opportunity to print this page if you would like, or if you don't have a printer, no big deal. This will actually work very well on loose leaf paper or even just plain white paper. I just recommend that you use the landscape model. So let's get ourselves started. Let's start off with a definition of the quantum mechanical model. So the quantum mechanical model is the modern description of an atom's or ion's electrons or position. So this helps us to know where we might find an electron. And so I've got a picture up here, and you can see all these dots. This atom doesn't have all of these electrons, so each dot is a little electron. But it's showing all the possible positions. And so this is a statistical model, and it is based upon several mathematical equations. Now, the good news for you is you don't have to know those mathematical equations. So that's good. What it ends up doing is it places electrons in a three-dimensional cloud of probability. So sometimes you'll hear this as the electron cloud model. And those electrons are all around the nucleus. So I'm going to say that one more time. The quantum mechanical model is the modern description of an atom's or ion's electrons, their position, and it's based upon mathematical equations like Schrodinger's equations, Heisenberg, all sorts of folks. It places electrons in a three-dimensional cloud of probability around the nucleus. So sometimes we call this the electron cloud model. You can see where this looks like a cloud. All right, now some of this stuff that I'm going to be bringing to you in the first video, you're going to be like, what is going on? This doesn't make sense. But I promise you that if you hang on with us through all of our video series and our live instruction, you will have a great sense of satisfaction because it will all come together. And so I'm going to ask that you just have some trust in your chemistry teachers and know that we are going to guide you along the way. So the first thing I'm going to talk about are sublevels and orbitals. So we have the S sublevel. I like to say that it's called S because it is a sphere shape. Now a sphere, in essence, is a circle, but it's a three-dimensional circle. And I'm not a great artist, and you might be a great artist, but I'm going to try to shade this a little bit. And I'm going to try to make this appear as if it was three-dimensional, like a basketball or a golf ball. Okay, now you guys can see that I'm really not a great artist, but I'm trying. Okay, now this particular sublevel, the number of orbitals that it has is 1. Okay, now listen. When we draw diagrams, we could draw this sphere every single time, but quite frankly, that's not really easy to do. And so scientists have gone ahead and made what we call an orbital diagram. And the great news is that we can all draw the orbital diagram. So one of these spheres is going to be represented simply by a box. So I'll just make a note here that one box equals one orbital. So you're going to see a lot of boxes. Okay? And then one orbital has a maximum of 2 electrons. So it could have 1, but it can have up to 2. Now, electrons are going to be represented by arrows. And chemists are so lazy that we very rarely put the full head of the arrow on there like this. We just make half of an arrowhead. And one is going to point up and one is going to point down. And we'll get more into that later on. All right, the second one that I want to talk about is the p sublevel. I like to call it the petal shape. Reminds me a bit of a flower. This is one of my favorite orbitals. It has 3 components to it, sort of like a graph. So it's got the x component. So this is the entire x component. I'll put a little x in there. It's got 2 parts to it. Then there's a y component, up and down, sort of like a graph, like I said earlier, kind of mathematical. And then we have a component that's called the z, and the z is coming out towards us, and then it's back behind, as if it's going back into the back of my page. So this really is sticking straight out towards me, but these are difficult to draw. And again, they're 3-dimensional, and these are going to describe the locations of where possible electrons could be. So we like to say the p sublevel has 3 orbitals. So I'm going to say orbitals equals 3. We've got the x, the y, and the z. And since it says that each orbital can have a max of 2 electrons, and there are 3, the max number of electrons in the p sublevel is 6. So how could we draw this? Instead of having one box, let's draw 3 boxes, and we'll draw them connected. So do you see I've got 3 boxes here? This whole thing is called the p. This is x, y, and z. And each one of these can hold up to 2 electrons. So 1 up, 2, 3, 4, 5, and 6 electrons. All right, now just as a little side note, there are also D, and I'm going to put a 5 next to that, and F sublevels. So S sublevel has 1 orbital, P has 3, D has 5, and F has 7. Now, when we do an electron configuration to try to describe where we might find an electron, we use this format here. This is the first place we always start an electron configuration. So let me tell you a little bit about that. Here, the number 1 is going to be equal to what we call N, or the N or G level. The S is what we've noted already. This is the sublevel. So this is a little bit like an address, okay? This is sort of like saying we live in Michigan, but we specifically live in Berkeley. And then what block do you live on? And this little number 1 is going to tell us, hey, we live here, and this tells us the number of electrons in the sublevel. That should be a little negative sign. All right, so far I've given you some information about how we might address or say where an electron might be. And I'm going to give you a couple of rules about this, or ideas that we want to keep in mind. And then we're going to plot this out on the periodic table. Now remember, if you're like, I have no idea what she's talking about, just hang in there with me. It'll start to come together over the next week. So the first idea or rule is each energy level, which we'll represent as N, is represented by a row, which we call a period, on the periodic table. Okay, so each row is going to be an energy level. In fact, if we look at our periodic table here, we might label that. And you can do this on a blank, you can do this on this printed sheet, you can do it on the periodic table that you've already created. So you'll see 1, 2, 3, 4, 5, 6, 7. These also are 6 and 7, okay, because they belong in here. All right, let's keep moving on with a couple more ideas. All right, the next is that each energy level is made of sublevels. Remember, the sublevels names are S, P, D, and F. Okay, so we said there's an energy level. Each energy level is made of sublevels. Okay, so this is like the state. It's made out of different cities. And we're going to get more and more specific to say where we might find an electron. All right, the third idea is that more specific piece. Each sublevel is made of orbitals. Okay, remember we used a box to represent an orbital because it's difficult to draw these pictures every single time. And the last idea, which we've already mentioned, is each electron is equal to an arrow. I'll just draw an arrow there. We've got two types of arrows. There's one that's called clockwise, and there's one that's called counterclockwise. Okay, and these are our electrons. All right, let's go on to our next page. This is where you need to get your periodic table, and we're going to mark out where we might find these items on the periodic table. And the great news is the periodic table is going to end up telling us exactly where everything is. There are a few exceptions, but we'll figure that out. Okay, so the first thing that I want to mention to you is we've already numbered 1 through 7 here. This is N, and remember N for energy level. That always helps me. Now, I'm using a blank periodic table. You might have a periodic table that has the elemental symbols on that, and that's great. And so let's work with that. I'm going to put an H here, and here's helium over here, and I'm going to put a little arrow saying, you know what, in this particular instance, it's important for us to keep helium over on this side of the periodic table. So what I'm going to mark off are our sublevels, and we call them blocks. And so my first block is going to be called the S block for that sphere. And I'm going to highlight just around here like this, and we're going to call this the S block. So this represents electrons that fall into that sphere. Okay? All right, let's move to our next block. Our next block we're going to find on the very right-hand side, and this is going to be the P block. So it starts at boron, heads all the way over to neon, okay? Nihonium and oganesson. Those are our 4 corners of the P block. All right, so I'm just going to highlight around here. Everything inside of this block is going to have electrons that fall within the P block. Okay, so I'm going to write P block above here. I'm going to highlight that. And I'm going to go back with my pen that I had earlier, if I can ever find where I put it. Oh, here it is. And I'm going to highlight this helium just to make sure I don't make a mistake. I know that that's in the S block. Okay, next we're going to show where the D block is. And I like to mark these elements over here. Okay, I'm also going to mark these SC, Y, HF, and RF. Now notice I left a space here. Okay, so this is kind of an unusual spot because remember these lanthanides and actinides actually belong in here, and lanthanide and actinide are often pictured there. And so we've got to be sort of careful with that area. So watch before you highlight or before you mark here. Here we go. This is actually going to be the D block. Oh, I think my green is running out. I might have to grab another one. All right, and then these two actually end up in the D block at the very end, and I'll put the letters down here, LU and LR, and this is YB, and I think this is NO, if I'm remembering correctly. Okay, how are we doing there, folks? Is this making some sense in terms of the fact that we are laying out the sublevels on the periodic table? Okay, I'm going to call it the D block, and D block is my green. I think you guys can see that. I know it's not real dark. Okay, and then finally our F block. And so our F block is going to start up here, LA and AC. I think I'm going to use purple for that. It's going to continue down here, CE and TH. And so I'm going to include this and this. Okay, and that is our F block. Okay, just a couple of other small notations that we're going to make on here, and we'll explain these a little bit later on. So I would like you to make a notation on scandium that this is 3D, and below it is 4D. Beneath that, we're going to make a notation where the lanthanides start, 4F, and AC is going to be 5F. Okay, now you might be squeezing that in there, but these are all of the landmarks that we're going to need in order to describe where each electron is in every atom that exists. So this is going to be a really big friend of yours. So if you've done it separately, make sure to keep this with your regular periodic table. If you've done it on the periodic table that you've already created, that is good because you'll have it all in one spot. But this is going to be an important tool. I would say that this is a key reference. All right, we're going to end here for today with video 1, and we'll pick up next time by going over our various energy levels, sublevels, the number of orbitals, and the total number of electrons in our next video. Thank you.